Graph the following. All right, in this video, we're looking at several transformations for the graph of y equals x squared. So remember, y equals x squared is basically a parabola, so it would look something on the order of this, right? This is basically what the parabola looks like. So that's the first graph, y equals x squared. It looks like a parabola opening up because the sign in front of the x squared is positive. All right, from here, let's compare that graph to the remaining graphs in the list. So the next one says y equals x squared plus 3. So I want to know, what does this plus 3 at the end of the graph do? Well, what it basically does is that plus 3 at the end of the function raises the parabola up 3 units. So you'd pick up its vertex, right, and move it up 3 units. So 1, 2, 3, and it would end up being right here. And otherwise, the parabola looks the same. It still opens up because it's still positive in front of the x squared, but because it has a plus 3 at the end of the function, it's going to lift the function up 3 units. That's because basically, once you plug in the value for x and you square it, you're just going to add 3 to whatever that result is. So all the y values will be moved up by 3 spaces. All right, so let's look at the third function in the list here. This is y is equal to x minus 3 in parentheses squared. So what happens when you have the number in the parentheses is that it actually moves the function in the opposite direction of what you would think. So you would think with a negative 3, we would move 3 places perhaps on the x-axis, right? So that's the first thing I want to talk about too, is that in the previous function, remember this plus 3 in the back end of this function actually meant that we moved on the y-axis up and down according to the sign of that number. So if it was positive 3, we went up 3 units. If it was negative 3, we'd move the function down 3 units. In other words, we'd move that vertex down 3 units, right? Now, in the function here on the right here, the third one in the list, that function has the 3 inside of parentheses. And so when it's inside the parentheses like that, when it's sort of joined to x, right, then that number is actually going to be indicating a movement or a shift on the x-axis. So minus 3 in this case is going to mean to move the vertex 3 units on the x-axis. The only one thing we have to figure out is in what direction. Well, minus 3 is going to be a move to the right. Now you'd probably think, hey, isn't the negative part of the x-axis on the left? It is, but everything is going to be opposite inside that parenthesis. So when you see that minus 3, it's actually going to be 3 moves to the right as opposed to 3 moves to the left. So we're going to basically move 1, 2, 3 over, put our vertex there, and then we have the parabola rising up from that point. All right, again, we're just sketching it. Of course, we could plot points, but rather than do that, we're just saying, hey, look, we basically know what the graph is going to look like because we have this idea of what y equals x squared looks like, and then we're using these transformations to get an idea of what happens to the function when we make these changes. All right, let's look at our fourth function here, the one that says y equals negative x squared plus 3. For that graph, basically we have the same plus 3 we had in our second example, but we also have a negative in front of the x squared. So what the negative does when it's in front of the x squared like that is it actually makes the function open downward. So instead of opening upward, it actually opens downward. You might think of a negative sign as being like a negative emotion, so you might think of a sad face and then think of the parabola making a frown instead of a smile. That's one way to remember which way it goes. So remember, a negative in front means it'll open down. The plus 3 means the vertex will rise 3 units again on the y-axis. So we're actually going to start here at y equals 3 and we're going to go down, right? So the parabola does like that. Again, so that's the sketch of our parabola, which is given by the function negative x squared plus 3. So we've moved our vertex up 3 units and we're opening down. Let's take a look at our fifth example here. This is the y equals negative parenthesis x plus 2 squared function. All right, for this one, we have a couple of things going on. First, we have that negative out in front, which means the whole function is going to open down, right? And then we have an x plus 2 squared. So remember, when you have that plus or minus number inside the parenthesis like that, it means that we're going to move the function along the x-axis somewhere, right? In this case, a positive 2 means we'll actually move 2 units to the left. That's counterintuitive again. Remember, we said that inside the parentheses, it's sort of opposite world, right? So positive 2 would normally think of 2 units to the right, but we're actually going to move it 2 units to the left because it's inside the parenthesis. So that means that the vertex is actually going to start here at x equals negative 2 and will open down. So the parabola will look like that. So let's look at our sixth example here, the y equals 2x squared function. So 2 out in front is going to basically stretch the function. it's going to end up staying anchored in the same place it's always been anchored. Because, if you plug 0 in for x, you're still going to get 2 times 0 squared, which is going to be 2 times 0, which is 0. So we're still going to get that point at the origin. The vertex won't move, but the function will rise a lot faster. Because if we were to plug 1 in for the function, right? So if x was to be equal to 1 in the function, we'll end up having 2 times 1 squared, or in other words, 2 times 1, or 2. Now, before, without that 2, if we didn't have the 2 here in front, we'd just have 1 going in, giving us 1 squared, which is 1, and we'd have 1 comma 1 as the point. But instead, now we get 1 comma 2. So basically, the function is rising faster than it did before. In fact, it's rising twice as fast, right? So what we'd want to see then is the function basically getting stretched upwards to be a little more skinny, essentially. So the function is basically being stretched, so it's not as wide as the original parabola, right? It's a little more skinny as it moves up. It moves up more rapidly. All right, so the thing to remember then about this number out in front is that the sign will just determine whether it opens up or down. So it doesn't matter if that was a positive 2 or a negative 2 with regards to the general idea of what's happening here. The negative would mean that it would open down instead of opening up, right? So the plus and minus sign still has the same rule. But if it's something like 2 or 3 or 4, or in other words, something larger than 1, you're going to expect the function to rise more rapidly, or in other words, kind of get more skinny, right? If it were to be a fraction, though, something between 0 and 1, it has the opposite effect. It actually gets wider. So y equals 1/2 x squared would actually be twice as wide as the original function, right? So if we had that, it would end up opening something like this, right? It would kind of spread out. So hopefully that makes sense to you. If you put a fraction between 0 and 1 in terms of absolute value, we're going to have it become wider. Of course, whether it opens up or down is determined by the sign. That's why we're saying absolute value, right? If it's negative 1/2, it does the same thing, just opens down, correct? All right, and finally, let's look at our last example here. Y equals parentheses 2x to the second power. So that function essentially is the same as saying y is equal to 4x squared. Or another way to think about it is, if you were to plug in 0, nothing changes, right? So if you put 0 in for x, then you end up with y being still 0 because 2 times 0 squared is still just 0. But when you put in 1, it becomes 2 squared, which is 4. So you end up getting the answer that you would have gotten had you put in 2 to the function originally, right? So basically, again, it's like twice whatever x value you get in there and then squaring that. So you get 1, 4 instead of what used to be 2, 4 as a point. So things are going to change a little bit, but basically it's going to change to be kind of like 4x squared. And not kind of, but exactly 4x squared, because that simplifies to 4x squared. And so what that basically means is that the function is going to rise 4 times as fast as it did before. So we're just going to have a function that's particularly skinny, right? Something like that. That's not the best drawing, but the general idea is there that the function rises even faster than it did before when it was y equals 2x squared.